So how to identify a function from an interaction matrix? First thing is the cell should contain a plus sign. Now, when there is a plus sign cell, realize there could be one function, there could be many functions, and there could be no functions at all. No functions mean they are touching, but there is no function of consequence to you. So you do not add that function into your function model. A cell which has a negative sign there will not contain any function. This we are clear of. We just discussed the necessary condition for a function to happen is that there should be a plus sign in the interaction matrix. Otherwise, the function cannot be there. So then we label, we'll use the legend as B for basic, AX for auxiliary, AD for additional, harmful, insufficient, excessive, and normal. Okay. So we create this legend, and then all we need to do is we form a table. We make a table of what are the functions that exist. So let us look at the paint example of yesterday. So yesterday, Jaskirat was asking what happened to the paint example, what happened there. So now we look at that. So in this particular thing, what is the target? What is the target of this system, paint filling system?
So the coloring of that object, basically.
That component.
That is painting of that object.
Paint filling system. नाम में ही टारगेट है. Paint is the target, bhai. The main purpose of the paint filling system is that, what is the paint filling system? This is the paint filling system, na?
Yes, sir.
So ये system क्यों exist करता है? So that I could move paint from the barrel into this, na? Into this tank. Are you able to see this?
Yes, sir.
So what is the target here? Paint. What would be the basic function? In all this, which component would be performing the basic function?
Motor.
Tank.
Pump. Pump moves paint from the barrel to the tank. है ना? मोटर तो पंप पे एक्ट करती है ना? So okay, let's go into details of this. We first make the interaction matrix जो हमने कल बनाई थी. You remember we had made the interaction matrix? So this is the interaction matrix. Now we pick up each component and see what are the functions defined there. So let's look at float. Float moves lever and it holds paint. You see, it is touching lever and paint and air. There are functions between lever and paint. The fact that air is in contact with the float is not of much significance for us. Air is just there. So udhar koi function bana hi nahi. Then we look at lever. Lever holds float and it controls the switch. Now what we are saying is, because what was happening? The paint was overflowing. The paint was overflowing. Why did it overflow? Because the lever, the float did not move the lever sufficiently. So what did we say? That this function is performed insufficiently. Now, lever holds the float properly, that is acting normally, but lever is not controlling the switch sufficiently. Because if the lever was controlling the switch sufficiently, the switch would have turned off the motor, and then extra paint would not have been pumped in there. So the action on switch is insufficient. Now the switch controls the motor. For the motor, it is the switch that is not controlling it properly. So this action is insufficient. Now, when it comes to the pump, for the pump, motor is rotating the pump for extra time. It is happening excessive. That is where it is harmful also. Due to this, pump moves the paint excessively. And you notice we have put basic over here because paint is the target. Barrel contains the paint. It is containing it normally, no problem there. The paint is in touch with the float. You see, float was in touch with the paint, so float held the paint. The paint is in touch with the float, and as the level of the paint rises, it moves the float. But it is moving it insufficiently, because had it moved it sufficiently, the switch would have been turned off. Now, tank holds the paint or contains the paint. Again, it's a basic function. Again, it's a basic function, but it is being performed insufficiently, because of which there is a spillover happening. Now, air solidifies paint, and it is a harmful function. We're not even talking of whether it is sufficient, insufficient, or excessive. It is a harmful function. No further labeling needed. This function has to be removed. Is this clear till here? Any questions?
Yes, sir, clear.
Perfect. So now what we do is, now we will make a function diagram in a different way. Now we go to pen and paper. See, till now we were looking at the shaft floor view. In the shaft floor view, you were getting confused that the parts are the target of the paint filling system. Now, if you look at the entire shaft floor, for the shaft floor, that is the target. Yes. But for my paint filling system, the system where the problem is existing, for that the target is paint. So this kind of a confusion was happening. Now we do not want any further confusion like this. So we move out from this zone and we go into a function model, which is graphical in nature. And over here, you will notice all the insufficient functions we have represented with a dashed line. There is also an arrow that we have put here, which says that over here, for example, lever is the function carrier and switch is the function object for this controls. For this particular function, switch is the function carrier, motor is the object of the function. We've actually colored the target in a different color itself. The super system components are shown in a different color and system components are shown in a different color. Because of this color coding, right away I get to know what is happening, which functions are additional, which functions are auxiliary, which functions are basic. Can you tell which functions are basic by looking at this diagram? Which are the basic functions over here? Which are the basic functions over here?
Holes, contains.
See, we've represented hold as a harmful function over here.
Yeah, sir, contains.
So it cannot be a basic. It is not being categorized as basic or anything. It is a harmful function, has to be removed. Air solidifies paint, again, has to be removed. However, barrel contains paint is clearly a basic function. Tank contains paint is clearly a basic function. Pump moves paint is a basic function. Now it is performing this basic function excessively or insufficiently. That is why I put it in a dashed line. Okay. Is this okay? Any questions here?
Sir, why are we using normal lines and dashed lines? Can you repeat it again?
The dashed lines are to represent that something is insufficient or excessive here. In fact, I prefer to use for something that is happening excessively, I actually prefer to use a solid, very dark solid line. In this particular diagram, I have accidentally used a dashed line, Dashed lines are typically used when I want to show insufficient functions. Okay, dark solid lines, excessive function. Okay, is that fine?
And in normal lines, we are they are doing the normal function.
Yeah, they're doing normal functions. Red colored lines are doing harmful functions. Okay,
Yes, sir.
red colored lines are doing harmful functions. Blue colored lines are doing functions normally, and dashed blue lines are desired functions, useful functions, but either happening insufficiently. I would say happening insufficiently, and I would say you guys should use bold, thick lines to represent functions which are being done excessively. So visually, we are able to differentiate between all kinds of functions. Are you able to see this? I do not need this table now. It is so difficult to understand the function model from the table, is it not? Whereas as soon as I do this, it is so simple to understand. Are you with me?
Yes, sir.
Sir, one question here.
Yeah.
So, sir, have we made an assumption that the problem is at the float level? So, float is moving the lever insufficiently. It could be possible that the problem is at the switch or any other level. So, have we made this assumption?
Yeah. So यहाँ पे हमने assumption नहीं बनाया. यहाँ पे system का symptom था ये. यही तो बात हो रही थी. When we defined the problem, we said the float becomes heavy. Therefore, it does not rise sufficiently, and therefore the system is failing. So every 1 month we have to change the float, or we have to stop the system, and we have to clean the float, remove the paint from the float. When we described the problem, that is how we described it, na?
Right, sir.
So it's not an assumption. This is the problem statement. This is defined, already defined for us. Cause effect chain analysis has already been done. It is the float which is the cause, that we have understood. Is it okay?
Yes, sir. Understood. Thank you.
So that is why we did cause effect chain analysis before function modeling, so that you know where the cause is and then you model around it. Okay.